Hello and welcome to Water Quality. In this video, I'm going to go over some practice problems where we can use our knowledge of alkalinity. What we're going to do is look at a series of chemicals and decide whether or not the alkalinity goes up, goes down, or stays the same. So if I add sodium chloride to water, it's going to form sodium and chloride ions. And what you can see is that sodium is a CCC, so the summation of CCCs goes up, and chloride is one of the CACs, so the summation CAC is also going to go up. And those two things will go up at the same rate, so no change in alkalinity. Now, when sodium carbonate or soda ash dissolves into water, it forms two sodium ions and a carbonate. This is going to cause the CCC to go up because sodium is a CCC, it's a conservative cation charge, but there's no corresponding increase in CACs. Also, we can see that the carbonate is a part of the alkalinity expression. So it's pretty clear here that the alkalinity will go up, both because the CCC increases and also the carbonate or one of the carbonate species increases. Potassium sulfate forms two potassiums and sulfate in water. And so this is going to cause the CCCs to go up and also the CACs because potassium is a CCC and sulfate is a CAC. Now, one potential source of confusion here is that there's two potassiums but only one sulfate. But because the sulfate has a 2 charge, adding two potassiums is equivalent or has some equivalence to adding one sulfate because of the 2 charge on the sulfate. And so here, there's no change in alkalinity. Next, I'm going to consider hydrochloric acid, which donates a proton and also a chloride ion. Now here, the CAC is going to go up. I should also put an up on here. But there's no corresponding increase in CCCs because the hydrogen ion is not a conservative ion. Hydrogen ion is also in the alkalinity expression, but with a negative sign, so that will have, that will have a negative impact on alkalinity, so alkalinity will go down, both because the CACs went up, and that has a negative charge on it, but also the hydrogen ion went up, and that's negative in the alkalinity expression. Next, I'm going to consider the base sodium hydroxide, which dissociates into sodium and hydroxide ions. This is going to cause the CCC to go up because sodium is a CCC. And also, hydroxide is in the alkalinity expression. And we can see that it's a positive sign on hydroxide, so the alkalinity will go up. The next two are a little more confusing potentially. The first one is carbon dioxide gas, and or aqueous, it doesn't really specify. But one way to think about this is that carbon dioxide is not in the alkalinity expression. So not in alkalinity equation. And since it's not in the equation and we add it, there's just not going to be any change to alkalinity. There's also no increase in CCCs or CACs, so it's clearly not changing the alkalinity. The same can be said for carbonic acid. It's simply not in the alkalinity equation, and it doesn't change the CCCs or CACs, so no change. And finally, we have Dr. Litton's fish taco bonus. Does the alkalinity increase, decrease, or stay the same if I allow a water sample close to the atmosphere to equilibrate with the atmosphere? So what we have, like imagine a beaker of water, pure water, and then it's allowed to interact with atmospheric CO2. I do this in the lab by aerating a sample. And one thing that we need to note here is that CO2 can, under these conditions, can enter or leave the water, the solution. So let's say that CO2 enters. What that looks like is this. So we have CO2 dissolving into the water and reacting with water and forming carbonic acid. I'm going to put a star by it to be consistent. Now this can dissociate and donate a proton and form bicarbonate, and it can dissociate again and release another proton and form carbonate. What you can see is in each of these cases, for example, in the first two situations we have CO2 plus water or H2CO3 star, those things aren't in the equilibrium expression, so they don't change or the alkalinity expression, so they don't change the alkalinity. Now when we add a hydrogen ion and bicarbonate, those things will cancel out in the alkalinity equation. If we have two hydrogens and a carbonate, those will also cancel out in the equation, having the overall impact of no change in alkalinity. Now, same kind of thing happens if CO2 leaves the solution. And now what we have is the same thing but in reverse. So we have a hydrogen ion and a carbonate reacting and forming bicarbonate, which can react with another hydrogen ion and form carbonic acid, and that can dissociate into CO2 and water and potentially leave the solution as CO2 gas. And here again, when we take out a hydrogen and a carbonate, or take out two hydrogens, if we take out these species, they're going to have a net impact of 0 on the alkalinity equations, and then also the CO2 and H2CO3 are not in the alkalinity expression, so there is no change in alkalinity. And that's it for this video. Thank you.